Hi, everyone. Oops. Okay, here we are. We are ready to talk about similarity. We know all about ratios. We know all about proportions, so we're about to put it to work. Okay, we talked in an earlier video about the basic idea of similarity. So remember, it's kind of like congruence, except with congruency, if I wanted to prove that two triangles were congruent, or if I wanted to say they were congruent, what I was really saying is that the same exact size, same exact shape. Just one is the copy of the other one. And for similarity, that's not the case. Similarity is a little looser than that. If two things are similar, and this says polygons, which means any really straight-sided shape, right? Just not circles and stuff. We're going to focus on triangles at first, right? If they are similar, they're going to have the same shape, but different sizes. So like these two right here. Notice they're both triangles. They have the same exact even triangle shape, but this one is way bigger than this one. Okay, now we talked in the congruency when we were talking about proving things congruent. We said, well, is having all three angles the same a way to prove congruency? Look here, I have three angles that are the same here. These are not congruent. They are, however, similar. Because remember, all the angles can be the same. That doesn't make the triangles the same size. So the first kind of criteria for similarity is that all of the angles are going to be the same. Okay, so if all of the angles are the same, that's my first hint that I have some similar shapes. To check and make sure they're similar, that's where ratios come in. What I have to do is check the ratios of the corresponding sides. So just like with congruent triangles, we're going to have side pairs, right? In this case, for example, side BC and RQ are corresponding, right? They're the ones that match. Side CA and RP match. They're corresponding. And then these guys, AB and PQ, they match. They're my corresponding sides. What we're saying is we want to be able to take the ratio of this side to this side, and it should be exactly the same as the ratio of this side to this side and this one to this one. In other words, if I take the CB length and divide it by the RQ length, that better be the exact same thing as if I take this CA and divide it by that RP. And that better be the same as if I take this bottom one, BA, and divide it by QP. They're always going to be the same. Okay. This number that you get when you do this division has a fancy name, and that name is scale factor. So if I divide these numbers out and I get the same thing all three times, I call that number the scale factor. Okay. So if these doubled in size, if this was 10 and then this was 20, from 10 to 20 is times 2, we would say this has a scale factor of 2. Okay, we'll talk about that last one here in a little bit. We don't need to talk about that one right now. Okay, so when we talk about scale factor, notice that this says order matters. That's because it does. All right, so if I'm looking at these two triangles, right, if you want to talk to me about scale factor, I need to know, do you want me to go from little to big? Do you want me to scale it up? Or do you want me to go from big to little and scale it down? Okay, if your shape is getting bigger, okay, if you are going from little to big, your scale factor is going to be bigger than 1, right? In other words, if I'm taking a shape and I'm going to multiply its sides by a number and they're going to end up being bigger, that number better be bigger than 1. I'm multiplying them by 2 or 3 or 4 or 5. They're getting bigger. Okay. If I'm going from big to little, if I'm scaling my shape down, if it's getting smaller, then my scale factor is going to be less than 1. Okay, so let's look up here. This one says, what's the scale factor of ABC to DEF? So ABC to DEF. So it's getting bigger, right? If it's getting bigger, then my scale factor better be bigger than 1. Right? So I need to write these side ratios, but I need to write them in a way that my numbers are going to come out bigger than 1. In other words, I want to put the big number on top. So when I write these ratios, I'm not going to write 8 over 12. I'm going to write 12 over 8. I'm not going to write 10 over 15, right? 15 over 10. I want the big number on top, because if I put the big number on top, then when I divide it, it's going to come out bigger than 1. Now look, these might not look all the same, but if I reduce them, all 3 of these come out to 3 over 2. These are divisible by 9. These are divisible by 15. These are divisible by 4. Okay? So all 3 of these come out to 3 over 2. So we would say that the scale factor to take ABC to DEF is 3 over 2. Bigger than 1. That's 1.5. Okay, now, this problem is saying go the other way, right? Don't go from ABC to DEF. Go from DEF and work back. In other words, shrink it. Scale it down. Make it smaller. Now, if I make it smaller, then my fractions have to be less than 1. My fractions have to be little. If you want your number to be little, you put the little number on top. So now when I write my ratios, I'll do it the other way around, right? Instead of 12 over 8, I'm going to write 8 over 12. Instead of 10 over 15, or 15 over 10, I'm going to write 10 over 15. Instead of 27 over 18, I'm going to write 18 over 27. And those are all going to reduce to the same darn fraction, the same way they reduced up here, except now it's going to be flipped over. So it's going to look like 2 over 3. So notice when my triangle scaled down, my scale factor was less than 1. Okay, so look, here's what I want to tell you. We always talk about triangles, 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 right? Fact is, this works for any shape, right? See these two? What are these called? 1, 2, 3, 4. Quadrilaterals. If they're similar, all their ratios should be the same as well. So watch. Here's a pair. 6 to 4, right? That reduces, those are both divisible by 2, to 3 halves. Here's another pair, 6 to 4, also 3 halves. Here's one, 3 to 2, 3 halves. And last but not least, 9 to 6. Uh-oh, is that going to reduce to 3 halves? These are both divisible by 3, 3 halves. So we can say these are similar because all of my side pairs have that same 3 to 2 ratio. Okay. All right, here we go. Let's write some similarity statements, shall we? Remember congruency statements? We have to line up the parts. We have to do the same thing with similarity statements. Okay, so first things first. Symbol for congruency was an equal sign with that little squiggle across the top. The symbol for similarity is just the squiggle. All right, so if I want to say that two triangles are similar, I'm going to name the triangles, put the similarity symbol in between. But I have to make sure my parts line up. So if I'm going to say triangle ABC, then I need to make sure the letters down here line up the same way. So I went A, B, C. I went, let's follow my angles, 1, 2, 3. And down here I need to do the same thing. 1, 2, 3. It's going to be D, E, F. So that's important. When the triangles start getting turned around and upside down, we can always go back to the name to find our side pairs. Remember, the name is going to tell me. So side AB is going to correspond to side DE. AB to DE. Side BC is going to correspond to side EF. So if you can't really just quickly see it in the diagram, you can always go back to the name to figure out your side pairs. So it's really important that those letters line up. Okay, so let's write some congruencies, or not congruency statements, some similarity statements for these guys. Okay, I'm going to start, and I'm going to do this, start in this bottom corner and go around this way, right? So A, B, C, D. A, B, C, D. Let's do the same thing over here. I'm going to start in this bottom corner, and we'll go it around. M, N, O, P. Let's start at the top and go around clockwise. Okay. If I start at the top and go around clockwise, that's going to be D, C, B, A. D, C, B, A. Right? Do the same thing over here. Start at the top, go around clockwise. P, O, N, M. P, O, N, M. I don't care what order you put these ones in. Make these match. Right? I could get crazy and go A, C, B, D. Like go from here to here to here to here. That's crazy. It's madness. Okay, cool. Well, you better do the same darn thing over here, right? You better go M, O, N, P. Now, here's the thing. We don't usually do this, right? You don't usually jump across. That's crazy, right? What we generally do is pick one and then go around. Okay? So instead of jumping around like this, usually what we would do is just pick a place to start. I don't know. Let's start at B and go around clockwise. So B, A, D, C. If I started at B here, then I need to start at N over here. So N, M, P, O. Okay. I don't care what kind of shape it is. Pick a point, work your way around, and then do the same thing to the other one. You'll have a valid congruency statement. Okay, so let's work on a couple of problems. So, it says list all congruent angles and write a proportion that relates to the corresponding sides. So let's see here. I might not be able to see at a glance which angles correspond, which angles go together, right? But I can tell from the name. The name gives it away. J goes with P. So this angle right here goes with this angle right here. K goes with M. So K and M. So angle K is congruent to angle M. And then, and last but not least, L and M. So L and N. So I know that angle L is congruent to angle N. Now, I got to write the side ratios. They say write a proportion, right? That just means two ratios set equal to each other. So again, I need to make sure I'm lining them up right. So side JK, what side does that correspond to over here? JK, from here to here. Okay, so that would be from P to M over here. See? Look, JK, PM. That better be the same as the ratio of, let's say, KL, which takes me from circle to star. Over here, MN takes me from circle to star. And then last but not least, what's my third side here? I did JK, KL, oh, LJ. LJ goes from star to squiggle, so I need to do the same thing here. Star to squiggle, that's NP. All right, so if you tell me two things are similar, like they did here, notice this is similar to congruency, but before with congruency, I could write 3 angle congruencies and 3 side congruencies. Now I can't do that. I can write 3 angle congruencies, and then I can write the 3 side ratios must be the same. All right. So I want you to take a moment and I want you to do number 3. Okay. It's 4-sided figure. So you're going to have 4 angle pairs. Use the name. And then you should be able to write 4 side ratios. Okay. Go for it. All right. So let's see. What do we got here? Angle J goes with angle Q. Angle K goes with angle R. Angle L goes with angle S. And last but not least, angle M goes with angle P. All right, there's my angles. Now, sides. KL There's the two middle letters here. So I'm going to go up here, RS. That's one side ratio. All right, let's see. LM. LM is the last two letters, so that goes with SP. All right. JM was the first and last, so that goes with QP. See how this shape is flipped over? It's goofy. JM and PQ. And then last but not least, I've got JK and QR. Now listen, I don't know how big they are, but I know that those ratios are equal because they're similar. So if you can give me even one pair, then I'll know the ratio. And then if I know one side, I can figure out the other, right? So if I can tell you that this is double from here to here, then if you tell me this is 2, I know this is 4. If you tell me this is 10, I know that's 20. Once we figure out the scale factor, we can use it on any of the side pairs. Okay, so next time we talk, see what's happening? Here comes the X. I can't wait. All right, we will see you soon. Put any questions that you have about similarity in the video. Thank you.